everyone. In the last video we discussed about the concentration term, in which we discuss about the percentage by mass and percentage mass by volume. Today we are going to discuss about the molarity, the next concentration term, which is molarity. Definitely the molarity is a concentration term which involves volume, so definitely it will depends on the temperature. So how we can define the molarity and what is important about this? So molarity is number of moles of solute present in 1 liter of solution. So it is to be noted that to find the molarity by using the different data, it is to be noted that we must require to calculate the moles per liter of solution. So simply we can say that focus on the moles, how we can calculate the number of moles and the volume of solution. So capital M, that will be equal to N solute, moles of solute, divided by volume of solution in liter, that can be written as N solute divided by volume of solution in ml into 1000, and for moles we can write that W solute divided by capital M, molar mass of solute, into volume in ml into 1000. So this is the expression of molarity, and obviously from this expression we can say that for same number of moles, so for same number of moles, if any same, then if V increases, then molarity decreases. For same N, as volume increases, and we know that volume increases as in dilution, as V increases, dilution increases, so definitely molarity of solution will decrease. And we know that the molarity will depends on the temperature. So how it will be depends on the temperature? So as temperature increases, volume increases, so definitely molarity will decreases. Now how we can decode molarity? As suppose this is a bottle, and this bottle is labeled as 10 suppose this bottle is labeled as 2 capital M NaOH, and the density labeled as 1.2 gram per ml. So how we will decode this concentration term? Definitely we will decode like this, that 2m NaOH means 2 moles of NaOH. 2 moles of NaOH, definitely it is equals to the 40 gram, 40 into 2, which is 80 gram. So we can say that 2 moles of NaOH present in 1 liter of solution. So the moles of solute is 2 and the volume of solution is 1 liter. Yeah, we can say that it is 1000 liter. So now how we can calculate the mass of solvent by using this? So definitely mass of solvent will be equal to mass of solution minus mass of solute. So the mass of solution will be equal to the volume of solution into density, which is 1.2 gram per ml, minus mass of solute, which is 80 gram. So on solving this, it will be 1200 minus 80, this will give 1120 gram of solvent. And we know that the mass of solvent is required to calculate small m, which is molality. So this data is very much helpful, and this is decoding of a labeled solution. Now next we can take another concentration term, which is molality. and to be noted that molality is denoted by small m. And how we can define the molality? Simply we can define the molality moles or number of moles present in 1 kg of solvent. So it is to be noted that no need to get confused. Moles per kg of solvent is to be calculated to calculate the molality. Definitely one thing you should note it, that in all concentration terms we calculated for the solution, but for the molality we are calculating for the solvent. It is to be noted that moles present in 1 kg of solvent is called molality. So small m, that can be equal to moles of solute divided by W solvent, and W solvent, if we are taking the W solvent in kg, right? W solvent in kg. Yeah, we can say that this is moles of solute divided by mass of solvent. Mass of solvent, we are taking the mass of solvent in gram into 1000. So we can write this again, moles of solute will be equal to W solute divided by molar mass of solute into W solvent into, this will be equal to 1000. So this is the expression to calculate the molality of solution. Now it's turn how we can decode. If a bottle is labeled by 2m NaOH. So if a bottle is labeled by 2m NaOH, then the density is given as 1.2 gram per ml. So how we can decode this? So this is 2m NaOH solution. So we will say that 2 moles of NaOH. Yeah, we can say that 80 gram of NaOH. 2 moles of NaOH or 80 gram of NaOH is present in 1000 gram of solvent. It is present in 1000 gram of solvent. This is solvent, right? So this is the way of decoding. So how we can calculate the other parameters? Suppose it is required to calculate the volume of solution. You know that volume of solution is required to calculate the molarity of solution. Suppose this will be helpful when the molality is given and it is required to calculate capital M, which is molarity. It means that the relation between molarity and molality requires calculation of volume of solution also. So how we can calculate the volume of solution? To calculate the volume of solution, it is required to calculate the mass of solution. So this is the 1000 gram, which is the mass of solvent, plus 80 gram is the mass of solute. So it will make 1080 gram, which is the mass of solution, divided by 1.2 gram. This will give 1.2 gram is the density, which is definitely 1080 divided by 1.2 ml will be the volume of solution. So this is the way by which we can find out the molarity and molality of solution. One thing more we can relate in case of molarity and molality. How the molarity is related with the molality and the other concentration term we can discuss in the next lecture. Thank you very much.